Hello again, everyone. Good to see so many people here. Today we're going to hear about monitoring and logging in Kubernetes. I was on the program committee and was super keen on this talk because, spoiler alert, well, it's in the abstract, so you've probably all seen it. It references a project that I started called Loki. So Eddie's going to kind of show you how to use my code, which I'm also super keen. So round of applause for Eddie.
Thank you, Tom. How's it going, everyone? My name is Eddie Zaneski, and I serve the developer community at a company called DigitalOcean. Quick show of hands, who here has used a DigitalOcean tutorial before? Yeah. Fun fact, we are not just a tutorial company, we are a cloud provider. So thank you for that. So today, like Tom said, I'm here to talk about logging and monitoring in Kubernetes. And I just want to get a real quick gauge from the audience. We'll do like a 1 to 5. 1 being you are very new to Kubernetes or not have used it before, and 5 is your name is Kelsey Hightower. So can the ones raise their hand real quick? Level of Kubernetes? Okay, we got a couple. All right, 2s, please. Cool. 3s. Okay. 4s. Okay. 5s. Kelsey is not here. Damn it. Cool. All right, that's super helpful. So there's a lot of like mid-level. So I want you to take a step back to when you were a new developer. You might have heard of this thing called Kubernetes before. Maybe your boss walked into your office and dropped a book on your desk like my dad's boss did when Unix first came out. He said, here's Unix, go learn it. So I imagine you might have had some similar interaction like that. And I just really want you to think back to like how new the world was then and how scary and confusing it could have been, right? And so your boss is like, hey, we're going to start using this thing called Kubernetes. I want you to learn about it and go spin up a cluster somewhere. And so you might reach for your favorite cloud provider, so maybe Google, Amazon, Azure, DigitalOcean, really doesn't matter. You reach to some provider that has a managed service, or you're a masochist and want to deploy it on your own hardware. And so real quick, I'm going to run through creating a cluster, because it'll take like 5 minutes to spin up, and we'll just use it in the background. So I'm just going to pick London here. Let's get like a beefy 5 nodes. Cool. All right, so I'm going to copy this ID. And so we'll use this in a bit. Should be ready. And then I really want you to think to after day 1 is over, right? So you've spun up your cluster, you found your cloud provider, you're good to go, you've deployed your first app, your hello world, maybe you've got a couple containers running in there, you've spun up some load balancers. And then really comes the dawn of the second day. And this is where you're like, oh shit, I have a giant black box that I have no idea how to look inside, right? You have no idea, your old methods of logging and monitoring and having observability, they kind of get tossed out the window. Some tools might be familiar, but you really have to approach this from a very different place. You might be shipping off to a log server, so really just think back to like that first, day 2 when you had no idea. So maybe you wind up on this awesome landscape.cncf.io website, and you're faced with this really large and confusing map, and you start looking around, maybe you click some stuff, and you're just like, oh my God, like where do I start? And then thankfully you see over on the right side there's an observability and analysis section, right? And so this is broken up into monitoring and logging, and you see, you might see a few things you recognize from the past. So, we got like Datadog in here, New Relic, Nagios, some other stuff down there. And then, when it comes to logging, you see maybe Splunk, right? That's probably what's familiar to a lot of people, maybe Elastic. But some of these tools are definitely new and scary, and you're definitely going to have to pick up a whole new set of what's on your tool belt to get this to work. And so I'm just going to break this down. We'll split this up into 2 sections. We'll talk about monitoring first, and then we'll talk about logging. And so, I guess the first thing you got to do with monitoring is take a step back and figure out what you want to monitor. So, just like before when you had those, metal servers deployed or those VMs in the cloud, at some place you still have that concept, right? So you have your node somewhere. And so you need to get metrics out of those nodes, like your CPU usage, your disk usage, your memory usage, your network traffic, your packets that are dropped, right? All of these things matter. So your nodes are definitely where you need to start pulling some of that data. The way we do that right now, we have like exporters that we put on the nodes. We'll talk about in a second. Pods is probably the next step up, right? These are your actual containers and your pods that are running on your clusters. You want metrics out of those. You want to know how many pods are running, how many are supposed to be running. You could be watching these things, setting alerts if that number differs ever. And so, taking a further step down, you have your kube system namespace, right? So this is the namespace where all of Kubernetes core components are running, like the kube API server and the scheduler and etcd. So these things actually are really important, right, that you need to have insight and observability into. And then, taking a step further into your actual application, you have your APM, your application performance monitoring. This is where you're going to care about things like requests per second, the requests that are coming into your app, and error rates that are being thrown from your API or something, right? So we're drilling down a little further. And then you might have very specific app metrics that you're exporting. So let's say you have a web store, and this is your top selling product or something, right? So you can expose that as a metric somehow that you can watch on a dashboard. So, it depends on where you are in the company, where you are in the stack. The system people obviously really want to know what's going on with a lot of those nodes. The business people want to know which product is selling the most of. So this whole range of different things that you really want to get data out of. So these are some of the tools that I've worked with in the past. Datadog, Lightstep, Sysdig, Honeycomb.io, Influx Data. These are all really great commercial tools. Some of these have open source components that are out there. Datadog, has an agent that runs. It's a really great product. It can get really expensive too. So it's a favorite amongst a lot of people. In Honeycomb.io, it's definitely a newcomer from the scene, but I know a lot of bigger companies are starting to use something like that. So some of these might be familiar. Lightstep is actually what we use at DigitalOcean. We're a big fan of it. I got a page I'll show you later. But really, the core project that a lot of these metrics and the whole Kubernetes ecosystem runs around is called Prometheus. Anyone heard of Prometheus before? Yeah. Got a bunch of people, right? So Prometheus is a metrics system that it works in a different way than most have worked in the past. So this is a scrape method. So your Prometheus unit will reach out to your nodes and everything that works throughout the world and scrape metrics on some interval, right? Instead of your apps shipping them into Prometheus. So this works really well. And it works really well when you power this with something like service discovery, where Prometheus can go out there and find all of the things it needs to scrape without you telling it, right? It's like magic. And so the thing we're actually going to use is a thing called the Prometheus Operator, written by the CoreOS folks. It introduces some CRDs that are like custom resources, so you can create like a service monitor and some annotation magic. And basically what this means is Prometheus can just kind of go out there and start scraping anything that gets added to your cluster. It works really well. It's really easy to set up. So this is what we're going to dive into in a bit. And then obviously you need some place to display those metrics. The gold standard is Grafana. People have used Grafana before? Yeah? Yeah, that's a big room. Right, so Grafana is a pretty awesome metrics aggregation dashboard type dealie. So you can ship all of your metrics and data into Grafana and display them on very nice dashboards. I haven't worked at a company that has used Grafana before. So this is a quick high-level view of our metrics pipeline inside DigitalOcean. You probably can't see any of this stuff. The important things to call out, though, is we have like 4.5 million metric samples a second. Right now, that's actually doubled. We're doing 9 million a second because we're running 2 different hypervisor versions right now as we upgrade. And so this all magically works around this pretty cool thing called Pandora. It does some really awesome service discovery throughout all of DO. Tim Simmons gave a talk last year at KubeCon EU on how all this works. So if you're interested, check that out. So we've built everything around Prometheus. We absolutely love it. And then I also mentioned we use Lightstep. We use this for APM and tracing. This product is super awesome. I think we were one of the earliest Lightstep customers. This is just a quick view of our Kubernetes service. And it kind of breaks down really well all of your function calls and all of your spans and traces. And we're just super happy with it. So absolutely check them out for sure. And so that's really a high level of logging, right? So you have little data points that you need to put somewhere. And then obviously the next thing is logging. And so when we think about logging, what are the things you need to log? All the things, right? The 12-factor app says when it comes to logging, you should be logging anything that considers an event. Something happened that you really want to take care of. We have different log levels for different things. And so, the way Kubernetes does logging is you really want to write to standard out. So in the past, you might have written to a specific file somewhere for your application, and then some aggregator would have gone and scraped all those files individually. But the way that Kubernetes is really built to work well is if you just write to standard out. And all of those logs get funneled into an actual kube system log that gets written out to the disk. And then you can have daemon sets or some other service that actually pulls in that single log or that stream. So you really want to write to standard out when it comes to this. There are some log services that you can ship directly into that we'll take a look at. And it kind of goes against the way Kubernetes works, but there is an architecture to support that. So just log all the things until your team starts yelling at you, and then keep logging more. So. Some other loggers you might be familiar with. So we break this down into shippers and ingesters, right? Shippers are what's actually getting those logs out of your cluster. Again, Datadog, I think, so feel free to call me out on this on the Twitters, but I'm pretty sure Datadog is the only provider out there that does metrics and logging in one single agent that runs on your server, and it ships it off magically to the same place. So I think to get logs out of Datadog, you just stick an extra line in your config, and it starts doing it for you magically. So big shout out to them. I don't know of any others that do that. FileBeat's another one that's really popular in the Kubernetes world. This is out of the Elastic folks. So this is like a lightweight service that will find that log, ship it out to somewhere wherever you want. It's really a thin footprint there. Our syslog is what we use inside DO. We actually have a really huge our syslog collection. It pulls, our syslog has the concept of inputs and outputs, and we pull from a bunch of different sources, and then we spit it out to a bunch of different pipelines and transforms in different places. So these are some common ones that you might see. Some ingesters that might be familiar, again, Datadog does it all. LogZIO, Splunk. I'm a huge fan of Splunk. I've used it a lot in the past. But if you Google Kubernetes Splunk, there's really not a lot out there. So I imagine they're coming out with something cool eventually, hopefully. And LogDNA is another one. So really great tools. But again, Datadog's the only one that does all three of these. The biggest open source stack that you might be familiar with is the Efk Stack. Used to be the ELK stack, the Elk stack. You'd swap out this thing called FluentD with Logstash. But Elasticsearch is where you're going to ship your logs out to. You run this in your cluster, or you'd have a managed service somewhere. FluentD is actually the log shipper. This is a process that runs in Ruby. It takes a bunch of plugins. It's got a huge ecosystem out there. There are complaints about its performance and how much memory it actually takes up. There's a lighter weight version called FluentBit that's written in C that might be useful. But FluentD really does all the full indexing and ships everything out for you. So if you have high quality needs for all of those different bits indexed, check out FluentD. And then Kibana is the historic dashboard in the past for displaying logs. Who uses Kibana? Yeah, this stack's very familiar to folks, right? So this is pretty much one of the the standards for Kubernetes right now. But there's actually a new challenger that is approaching. Grafana, actually, as Tom mentioned, has a pretty cool thing they put out last KubeCon called Loki. It works really well. It's really light. It doesn't do things. It's a bit different than how a lot of the other ingesters work. It doesn't do all the parsing and as much indexing. So if you don't need all of that full text individual data searching, it works really well. It's super lightweight. It's composed of two different components, really. One's called Promtail. It's basically the reverse of Prometheus, right? So this is Prometheus for logs. Promtail actually will push out logs into Loki instead of pulling it. So it's a bit flipped there. But so Promtail will run as a daemon set on all of your nodes, and it will just ingest all those logs and ship them out to Loki. Loki's running somewhere in your cluster, ingesting all of that for you. And actually, Grafana 6 came out with a pretty cool view called Explore that we'll take a look at. And this actually lets you look at your logs right next to your metrics and dashboards and your Prometheus queries. So you actually do one-to-one correlation and click one thing and it pops over to the other. It's really cool. So I'll show you that in a bit. Just quick pipeline of our DO thing I mentioned. We use our syslog. We actually have 100% availability for log ingestion, which is pretty cool. This is across 10 plus regional aggregators, and we do about 30,000 log lines ingested a second right now. We're pretty happy with the setup with our syslog. It works really well. It kind of goes through a bunch of different transforms, like I mentioned, for different reasons. And so now we'll just pop right into the demo. So I'm going to use Helm for this. People use Helm? Yeah, a little familiar. Helm's like a package manager for Kubernetes. It's got some different manifests that we can deploy. It does templating really well. There's a big open standard Helm repo called the charts repo with stable. It's like all these like packages that are community managed. A lot of these can be configured, so you definitely want to check out the readmes on these. It's got some pretty sane defaults out of the box. Generally, they won't turn on things like persistence, though, so you want to make sure you read the docs so you can configure that. And so hopefully our cluster's spun up by now. Let's see. Looks good. Everyone see this OK? Yeah? I can make it bigger if not. So I got to grab that. Let's see. Kubernetes, cluster, kubeconfig, save. So we'll grab that kubeconfig, make sure our nodes are ready. Yep, looks good to me. There's that 5-node cluster. So I've got everything here in a make file to save time. These are some basic commands, though, so we'll run through them. I also have all of this on GitHub, so I'll show a link to it at the end if you want to grab this. But after spending, probably the past, year and a half doing nothing but Kubernetes, working with people who are brand new to Kubernetes, I've seen a lot of folks struggle with different parts, right? The number 2 questions I get answered are how do I do logging and how do I do monitoring? So this is definitely where a lot of people are getting stuck. This is a pretty simple stack that I've put together through trial and error. I've played with a lot of different products. It'll get you started. You definitely want to read the docs. You definitely want to read all the values that you can configure in the Helm charts. But this is definitely a great place to get some insight into this black box that you have. So the first thing we got to do is we got to configure Helm. So I've got a little command here. If you've used Helm before, it probably looks familiar. You have to actually create like a service account. You got to create cluster role binding, and you got to create that role and initialize Helm on your cluster. Right. So this is going to install Tiller, which is like a service-side component that will listen to API requests, put all the charts, compile the YAML, spit it out, and then Helm version 3 actually gets rid of Tiller. So a lot of these steps will actually be omitted, which is cool. So internet is not doing well. Come on. There we go. All right, so let me just make sure that's done. So we'll look in the kube system. So we just got to wait for Tiller to finish. It should be good by now. Let's see. Yep, there we go. So cool. So Tiller's done at the bottom there. And then the next thing we'll do is we'll install the Prometheus chart here. And so I've got, just using the very standard stable Prometheus chart, I got this custom values file. There's just a couple things in here that I configured to make things work a little better. So we got to turn off etcd monitoring. Generally, cloud providers will lock down their master nodes, so you can't get on there. And etcd is a side effect of that. So most cloud providers don't give you direct access to etcd, so we're just turning that off. I got to change a couple ports in here. We put firewall rules on our clusters, and so I just have to bump up the Prometheus node exporter. So this is actually what runs on those nodes. That's going to be shipping out actual hardware data. So we just got to bump the port up into a range that's in that firewall. Got to set a Grafana password. I'm turning on persistence. That's going to set like a 5 GB disk. And then up here, same thing with Prometheus. So this is the disk for Prometheus. So if we deploy that, so Helm's going to go out and do this. And that shouldn't take too long. And so while that's running, we'll take a look at the next thing. So Loki is what we're going to do next. So right now, Loki's not part of the stable charts because it's like, is it alpha, Tom? Yeah. Not even alpha. So this is not even alpha. It works really well. There's a bunch of people on the Grafana Slack that are actually running into production. The community is pretty great, so hop on the Grafana Slack if you actually want to get involved there. I actually haven't run into any problems. It's been very stable for me. So we got to pull down actually I did in the Helm thing, you got to pull down the Grafana Loki chart from above. And so we'll just install that. We're going to set a couple things like persistence, like I mentioned before. And then that's really it. So we'll do a make Loki here. And it's going to go out and deploy that. And then let's do a watch. And so it's going to create some of those disks. It's going to deploy some of those pods. Shouldn't take too long to get through here. While that's running, I'm just gonna, we actually just shipped an insights part and built into our managed Kubernetes stuff. Every cloud provider has one. They work really well. So this is like some super high level metrics that you can take a look at. These are exported right from the nodes. You can also install like Linkerd and some kube state metrics in here. But it gives you a quick base. Basically, every cloud provider will give you something that's like this. And we're just waiting for Loki to finish. Let's provision in that volume. So while that's running, we can actually. So I didn't expose Grafana with a load balancer, so we just got a proxy directly port forward to our cluster. And so Grafana should be up and running, which it is. And let's also just deploy like a sample app in there real quick. So Buoyant's the people who behind Linkerd have a really cool sample app called Emoji Voter that works really well. So I'll run that so we can just get some metrics being deployed. So cool, Loki's done. I'm gonna log into this cluster with admin and TacoCat, which is the best palindrome of all time if you didn't know. And now we can actually, the first thing we gotta do is we gotta configure Loki as a data source. I think there's a way to do this automatically in the chart. I haven't figured it out yet though. But you just come in here and you pop in Loki with the service discovery, so just the service name, and then port 3100 is what it runs on. Click save and test, and it's just connected like that. And then, so we'll just take a look at some of the metrics that we get out of the box for free. I'm actually going to switch over to a different cluster that I've already done this on that's generated a bunch of data already. So let me just do that. So that's really all the setup that's required. So basically what we had was a full logging pipeline and monitoring pipeline. So I'm just switching to a cluster that has some more data here. And I haven't configured this any differently. So there's some really great dashboards that work out of the box in here. So like this use method dashboard that apparently Tom built. It's got your full cluster overview. Pulling from Prometheus, you can take a look at all these bits here. And I'm also going to run a scaling script that's just going to scale some services up and down to generate some more load. Right? So these dashboards work really well out of the box. You can take a look at the namespace one in here. So I have a couple different microservice demos built out. Google's got one that's my favorite, actually. It's their hipster shop. It's under Google Cloud Platform /microservice demo. It's built with a bunch of gRPC stuff. Really cool demo to go through. So I've got that running under default here. And then Sock Shop's by the awesome Weavework folks. And then Emoji Voto is by the Buoyant people, right? So you can take a look. You can see all these insights and these metrics that come out. And then let's drill down a little further. Let's say we want to look at some actual pods in here, right? So I want to grab, let's say, Emoji Voto pod, and I got this little vote bot that's running. So this is going to be scaling, just voting randomly. So Emoji Voto's got like you can vote for an emoji that's your favorite. And so there's a bot in here that will just run and vote for stuff randomly. So the dashboards are cool. You can take a look around in there. To take a look at the logs, we actually just go to this Explore tab that I mentioned. You make sure Loki's picked as a data source up here. And then you can come down and let's just grab all the logs out of the namespace. We'll grab the Emoji Voto namespace. Right, and so boom, there's all of our logs aggregated right there. You can take a look, there's some votes going in here. We can see some errors. The Emoji Voto demo, anytime you vote for a donut, it throws an error. So we got some errors that are thrown in there. And then we can do that split that I was talking about. So here we can split that, go back to Prometheus, take a look at those, let's see, where's job? Container. Right, and so let's say we just want to grab this query. It'll warn us we need to throw a rate on there, right? So if you had a very specific thing, so if Emoji Voter was exporting Prometheus metrics, we could take a look at the Prometheus metrics that are exported and then match them up with the logs to have like side-by-side insight right there, right? So you don't actually have to like open another tab, go someplace else, copy paste. Like this view is really awesome. It's got everything here. And then if we pop back, we'll close this one. We'll look at Emoji. You can turn on the labels for the logs here, and you can see, oh, like maybe this error is only coming from this individual pod. It might be hard to see. So it's got this little magnifying glass that you can click here, and it will add it to the top. So now we've drilled down only into this individual pod's vote bots, and so you can see it's got a bunch of errors that are logged out there. It's voting for donut quite a bit, right? And so it's a pretty powerful system. It works really well. I haven't had any trouble. And like I said, the real power is how this really plays together. So from there, you could configure. Prometheus has the alert manager. That's how we trigger alerts at DO. You could configure the alert manager. I'm pretty sure it's part of the Prometheus Operator chart by default if you want it. And then you can go in there, set up alerts. Service discovery for alerts is something that we definitely want to work on in the future. We would love for alerts to be created really based off service discovery and some other stuff. We do it a bit right now. The real powerful bit, though, like I mentioned, was just having this high-level overview. And so, if you're getting started with Kubernetes and you don't really know where to begin when it comes to taking a look inside this black box, this is really a great place to start. So like I said, I have a link to the GitHub repo. And let's see, I'll put that up real quick. So this is a link to the GitHub repo. It's got that make file in there. It really goes through all the different bits. Feel free to grab it, play with it, comment it. Really take a look at that Helm charts, though. Like I said, they're very configurable. Got a bunch of data in there. And then there's a link here. If you can go to this do.co/c, this is our current survey, a little plug. If you could take this survey, it would help us a lot. It's about remote work culture. So if you work remotely or want to, we're just collecting a bunch of data. We publish all the results, and we'll send you this really cool SAMI remote sticker if you take it. So comms team asked me to do that. So please do that. But that's really all I have for the demo. I'd love to answer any questions. I think I got like 9 minutes left. Cool. Thanks, guys.
Thank you very much, Eddie. Guys, can we stay seated until the end of the talk, please? Thank you. Right, who's got a question? Start over here. I'm running.
Hi, my name is Sergio. So you actually said that we should log all the things. I would like to know how DigitalOcean deals with this, or what's your take on, because I understand as a developer I want to see basically everything, or as much as I can, but then as a sysadmin or DevOps wannabe, or sorry, I don't know what they are calling it nowadays, I need to not spend so much money, right? So if you if you log 2 lines instead of 1, then that will add up to probably a lot of money. So how is your suggestion to deal with that?
Yeah, so the question is how to really make a decision on what to log and how much. It really comes down to what your business needs are. If you have high-level auditing where you need to log every single interaction ever, to get some data out of it, maybe that's what you need for a business. But in terms of like the 12-factor app, they really suggest to log all of events. So whenever something that triggers that's considered to an event, that should be logged. At DO, our team has this. I've heard many times that the observability team has said, hey, stop logging so much. It costs us a lot of money in storage. It's really, obviously, if you're logging something that's not super useful, you probably shouldn't be doing that. But if it's an actual event or something that would help you solve a problem, right? Because when something goes wrong, you want to get to identified of the issue as quick as possible, right? So you want to identify the issue, figure out what to fix, and fix it. And if logging extra solves that, maybe it's worth the extra, a couple $100 a month or something. So it really comes down to your needs individually there.
Question from this part of the room. Anyone? Okay, over here. Anyone got a question? In the middle. Too late.
Hi, I was wondering, you run Grafana, we do too, and perhaps Loki and Prometheus inside the cluster you're actually observing. So, yeah, as we experienced, if stuff goes really wrong, then also your observability tools suffer, which makes it all the much harder. Do you have any tips in either hardening the observability tools or moving them external?
Yeah, so the question is, you're running your observability inside your cluster. What if everything breaks and goes to hell, right? So you have no idea. So Seth Vargo from the Google Cloud team spoke at HashiConf last year, and he mentioned that if you're running Vault in production, you should absolutely be running Vault in a separate Kubernetes cluster. And so your main cluster should talk to your Vault cluster. And that's in terms of security and policy there, right? I imagine the same carries over to your observability. So if you run your observability in your pipeline in a separate cluster, you're not having all your eggs in one basket there. All of these tools support pretty high availability. You can run these on different nodes. You can distribute them there. You can pay for a service to ship everything off and store it in there. So yeah, you definitely, in terms of like a demo, running everything on the same cluster gets the job done. But in production, in the real world, you might not want to wind up there eventually. So good question.
Hello, Edu. Thank you for a great presentation, first of all. The second thing, I have two simple questions about the Loki, if you didn't mention. I tried this system some time ago, like a POC, and I didn't know how to make the retention policies, the rotation of metrics in the data source. And the second thing, I thought the guy just asked about the how to decide what metrics are really the most important. This is the two questions. Thank you.
Yeah. So first question, if I understood correctly, you're asking how do you handle like log rotation? Yeah. So if you're writing the standard out, Kubernetes actually runs log rotate itself. So either the kubelet or the API server, something on a Kubernetes node will run log rotate for you and swap those logs out for you under the hood. So that's why you really want to log the standard out. Kubernetes will take care of everything. And the other question was, how do you know what metrics you want to grab? It's really, again, it comes down to your business needs. Some folks need every single metric reported. Obviously your node and your hardware metrics, that's a base. Everyone wants to know how much RAM they're using. But in terms of like your app-specific metrics, things that most of the Prometheus, so Prometheus has two parts of like getting data. One's called instrumentation and one's called exporters. So exporters are something that will run on your node, so get the data out of your node. It's a node exporter. And then instrumentation is code you can write into your apps. And so when you separate these two things, instrumentation comes down to maybe you want the error rates that get failed. Maybe you have most of there's like interceptors for gRPC and Kubernetes Prometheus Prom HTTP out of the box will tell you your HTTP error rate. It works magically pretty well. And so those things are pretty core staples. Outside of that, Prometheus is a time series database. So whenever the scraper reaches out, it hits the exporter. The exporter doesn't have to have any concept of time. It just has to respond with the current metrics. And then the Prometheus query language is what you'd make a query over to like at the rate over 5 minutes or something. So Prometheus just takes all the metrics. It stores everything as much space as it has. So.
Any more questions? Sorry, he's closer.
Hi, Ami here. The Prometheus operator, I didn't use it yet, is making it's supposed to be making it easier to deploy Prometheus, right? So would you suggest to deploy one Prometheus instance per application, for example, per namespace, and then have one Prometheus that collects the data from all the other Prometheuses, or what would be the pattern to do it right?
That's a great question. So he's asking, so Prometheus Operator makes it very easy to deploy multiple Prometheus Prometheuses in your cluster, right? And so it keeps watching. That's what a operator really does. I don't actually have an answer to that. I really don't know. I'd imagine that you'd there'd be no harm. Prometheus is a pretty light footprint. Storage is the biggest thing there. So as long as you're attaching volumes, I guess in terms of your security policies, if you want things, but I've heard many people say they just give every different team in their organization a namespace and they let them run wild, right? So I imagine your core platform team would install the operator and make it available to everyone to pull into a namespace if they want. So good question, though. I don't actually know.
Sorry, that's it. We're out of time. Thank you very much, Eddie.
Thank you, everyone.